Welcome back to Teacher Gimble's channel. Today I'm going to go over Illustrative Math, Algebra 1, Unit 1, Lesson 3 practice problem set. Now this builds on Lesson 2, so if you're not familiar with the topics from Lesson 2, I would recommend you going back and checking out that video. You can find it linked in the comments below. Let's get started. Problem number 1. The box plot represents the distribution of speeds in miles per hour of 100 cars as they pass through a busy intersection. So the first thing I do with a question like this is I situate myself with the graphic that I'm given. So we've got a box plot here, we've got some numbers on the bottom, those represent the speeds of the car mile per hour. And if I'm familiar with a box plot, I know that this will be my lowest value. So the slowest car is going 8 miles per hour, and this is my highest value. So the fastest car is going 44 miles per hour. So let's get started with a question. What is the smallest value in the data set? Interpret this value in the situation. Oh, we just did this. Slowest car is going 44 miles per hour. Now the rest of these, I'm going to talk out the answer and not write it down. So if you need to pause my video, feel free to pause my video if you need a second to process or write down the answer yourself. What is the largest value of the data set? Interpret this value in the situation. So we already figured out our min is down here, our max is up here. So the largest value in the data set is going to be 44 miles per hour. And what this means is the fastest car is going for 44 miles per hour. Question number 3. What is the median? Interpret the value in the situation. So the median is always going to be the line in the dot, in the box. In this case, we see the line aligns with a 20. So it's going to be 20, and the 20 represents miles per hour. So 20 miles per hour. Now, the median represents, as you heard in my last video, it is the middle value, which means that 50% of the data is below that value and 50% of the data is above that value. So what we know is that half of the cars, 50% of the cars, are going somewhere between 8 and 20 miles per hour, and the other half of the cars are going somewhere between 20 and 44 miles per hour. So the 20 represents that middle value where half the data is below and half the data is above. Question number 4. What is the first quartile? And interpret this value in the situation. So we've just split our data into two halves, and I always like to draw it in two halves, just like that. And this right here is representing our quartile 1. So that value is 12 miles per hour. Now, this just splits the bottom 50% of the data into two halves. So, of the lowest 50% of the data, half of that, which is 25%, of those cars are going between 8 and 12 miles per hour, and the next 25% of cars are going between 12 and 20 miles per hour. The third quartile does the same thing with the top half of the data. So the third quartile is going to be this line over here, which is 24 miles per hour. So let's do a few different colors here. So this represents 50% of the data. That represents 50% of the data. Now our quartiles split it up one more time. Okay. Go to blue. So our quartiles split it up right here. What ends up happening is each of these represents 25% of the data. So we've got 25% here, 25% here, 25% here, and 25% here. And so the Q1 is just the middle of the bottom lower half of the data, and the Q3 is the middle of the top half of the data. Pause and listen to this video as many times as you need to really intuit this. It takes a little bit of a while because this is a complex idea, but I'm sure that you could do it with a little bit of practice. If you have any questions, put them down in the comments below. Let's go ahead and move on to question number 2. Problem number 2. The set of data represents the number of eggs produced by a small group of chickens each day for 10 days. We have our data right over there. Select all the values that could represent a number of eggs produced in a day. 7.5 eggs. Well, we don't have a half an egg, so we couldn't have 7.5 eggs produced in a day. 7.6 eggs. Well, we don't get 7.6 eggs, so that wouldn't be the typical number of eggs produced in a day. 7.7 eggs, again, we don't get a decimal number of eggs, so that would not be the number of eggs produced in a day. 8 eggs. Well, we see sometimes that the chickens produce 8 eggs, so yep, That is a value that is possible. 9 eggs. We see sometimes that the chickens produce 9 eggs, so that is also a value produced in the day. So those are the two answers for that question. Sometimes you just have to use your logic, especially when you're using statistical reasoning. The dot plot displays the length of pencils in inches used by students in a class. What is the mean? Okay, so if you remember from my last video, I wrote out all of the numbers, but in this case, we realized we didn't have to do it. So I'm going to cross out my lowest value and my highest value, looking for the middle value. I'm going to cross out my lowest, next lowest, next lowest, next lowest. And here I got to the 6 in the middle, cross out the top and the bottom, and I'm left with two middle values here. They both represent 6s, so whenever I have two middle values, I just add them and divide by 2, which go ahead and gives me a 6. So in this case, I just found the median. The 6 is equal to the median. Is this question asking for the median? No, the question is asking for the mean. But when we're doing math, it's important to notice that sometimes we make mistakes and we have to go back and ensure that we're looking at what the question is asking. So I found the median. That's useful, but it's not what the question is asking. It is asking for the mean. So for the mean, I need to figure out what all of my values are. So I have 1 5, I have two 5.5s, I have 4 6s, and again, I'm writing it out because for me, visually, that helps me see it. 6.5 here, and then a second 6.5, and then, oh no, a second 6.5, and a 7. So when we have a mean, what you do is you take each of the values, you're going to add them all up, and you're going to divide by the number there are. So let's write this out in a big equation. We got 5 plus 5.5 plus 5.5 plus 6 plus 6 plus 6 plus 6 plus 6 plus 6.5 plus 6.5 plus 7 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to divide that by 11. We're going to go ahead, we're going to put it in our handy dandy calculator, and we calculate 66 divided by 11, which gets us 6. So the 6 is inches because the question is asking us as inches. So the mean or the average length of the pencils used by a student in class is 6 inches long, which actually also happens to be the same as the median that we accidentally calculated, which makes sense. You'll learn later on by what type of distribution that we're looking at over here. Question number 4. The histogram represents the ages of 40 people at a store that sells children's clothing. Which interval contains the median? So again, first I'm going to situate myself with what I see. So down here we have ages. So there's a 0 and a 5 over here. We know it's a histogram, so we know this represents the number of people that are between the ages of 0 and 5. This over here represents the number of people that are between the ages of 5 and 10. This box over here represents the number of people. So I'm going to do something that's going to help me situate myself to this data. And I'm just going to write inside my histogram how many people are in each box. So I know that's a 10 right there. Let's redo it in black. I know there's 8 people between 5 and 10. I know there's 6 people here, 3 people there, 5 people over here, 3 people over here, and 4 people over here. Now I know my median value is going to be the one that's right in the middle. But instead of lining up all of those numbers, because it is a lot of numbers, I'm actually just going to do some mental math here. So this represents 10 people. So 4 and 3 is 7. And then over here gets me to 7 plus 5 is 12. So there's 12 people for over here, and there's 12 people over there. 15 people will get us over here, and there's 18 people here. So there's 15 on this side, 18 on this side, which means if we want to come to the middle, we're actually going to end up with 6 in the middle. So the interval would end up with these 6 in the middle. So the interval that we want to look at is between 10 and 15 because there's 18 people on this side and there's 18 people, including some of these in the 6 on this side. And if we go ahead and kind of calculate to the exact middle value, it would end up being somewhere over one of the people in here would be that middle value, which is between 10 and 15. Again, as always, feel free to pause and go back to try to make sense of what I did. So we had between 10 and 15. Our answer over here would be C. And that's a pretty tricky question. So if you need to look at it again, I definitely would go back and look at it. Now we're on to problem number 5. 2 questions left. We're almost done. Let's go. The data set represents the responses in degrees Fahrenheit collected to answer the question, how hot is the sidewalk during the school day? So here's all of our data. It's pretty hot. And it's all in order, which I like. Create a dot plot to represent the distribution of our data. Create a histogram to represent the distribution of the data. Which display gives you a better overall understanding of the data? Explain your reasoning. Okay, let's get started with our histogram. Now, in my histogram, we see our values go from 90 to 119. So I think I'm going to count by tens. So my bin is going to be, my first bin, let's do, is 90 to 100. My second bin will be 101 to 110. My third bin will be 111 to 120. Let's go ahead and count this up. So we have 1, 2, 3, 4, 5 values between 90 and 100. We have, actually, this is inclusive of 100. So it's going to be more than 5 because we're going to include those 100. So we have 1, 2, 3, 4, 5, 6, 7 values there. We have, nope, 2, 3, 4, 5, 6, 7, 8, 8. I can't count today. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3 values between 1 and 110. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 values down here. A histogram always requires an axis. I'm going to put my bins down on the bottom. The bins are always on the bottom for a histogram. And then my third category is 111 to 120. And over here, I'm going to include my counts. We're going to do 5, 10, 15. So 3, we're going to start with our lowest bin, not our smallest number. The lowest bin is 90 to 100, which has 8 values, which is going to be a little bit below the 10. So he's going to go right there. The next bin has 3, so we're going to put him a little bit below the 5. And then finally, we have this last pretty large bin that goes up to 14. Now you can change your bin sizes if you'd like to get a little bit better picture of where the data is. But in this case, I'm just trying to compare the distributions. So I made my histogram over here. Now it's time for the dot plot. Step number 1 to the dot plot. We're going to make our little table here. There are always 5 values that we need for the dot plot. We need the min. We need the max. We need, oops, I did that wrong. We need the one more table over here. So we need the min, we need the max, we need the median, which is the middle value. We're going to need Q1 and Q3. So the min is the lowest value, that's 92. The max is the highest value, that's 119. The median is going to be the middle value, so I'm going to cross out, as I did before. Boom, boom, boom. Which leaves me with 112 in the middle. I'm going to change colors to cross out with my lower half of the data. So my lower half of the data, the smaller 50%, I'm going to do it again. I'm left with these 2 in the middle, so I add them up and I divide by 2, which gets me 100. And then Q3, I'm going to do the same thing with the top part of my data. So cross out, cross out, cross out. We see we made a mistake, so we start again. We got that guy in the middle, so we got 118 plus 119 divided by 2, which is going to be 237 divided by 2. And 237 divided by 2 is going to be 118.5. And remember, decimals are friends. We're going to make our number line. Now I'm starting at 92. I'm going up to 119. So I'm just going to count by fives. 90, 95, 100, 105. Now it's important to make the number line before you make the box plot, because then our values are aligned properly. And then I'm going to make a line for my min, 92, a line for my max, 119, a line for my Q1, 100, a line for my median, 112, and a line for my Q3, which is 118.5. I'm going to go over here. I'm going to connect the 3 middle dots and then draw my whiskers. Now, which display gives you a better overall understanding of the data? Explain your reasoning. In this case, I think that you could make an argument for either value here. You just need to make your argument have reason. I would choose the box plot, that it has a better understanding of the data, because I see that our data is skewed to the right. So even though the median is over here, lots of our data falls out at that higher value. However, this over here tells me exactly how much of that data. So maybe visually it's less impressive with how big we can see the spread over here. But over here, we can visually see that there are a lot of data that falls out between 111 and 120. Even more data than these two boxes combined. So you can choose which one gives you a better understanding of the data. Just explain your reasoning, and that will be an accurate explanation in this case. Finally, our last question. What is the area of the floor of this classroom? A statistical question. Explain your reasoning. For this, we're going to go back to what makes a statistical question. Now, if I asked every student in this class, or in your class, or who's sitting here right now, what is the area of the floor of this classroom? Every single student will have the same answer. The area of the floor does not change. Because everybody has the same answer, we know this is not a statistical question. A statistical question is when the answer changes from time to time. So in this case, is the area of the floor of this classroom a statistical answer? The answer is no. Anyways, we have just finished lesson 3, problem set. If you have any questions, please leave them in the comments below. As always, please like and subscribe if you want to see more videos like this. I'm happy to make anything that you need, but I need to know, and I can only see that in the comments. All right, thanks for watching. I will see you at the next time.